Welcome to the FCICA webinar series. Thank you for joining us for the why, what, and how of concrete moisture testing. This webinar will be recorded. The recorded session will be housed on the FCICA Member Center and this educational portal. Mark your calendars for these upcoming webinars. Thursday, February 18, join us for preparing the substrate and installation of flooring with EnviroStix polyacrylic adhesive, presented by Bill Weiss, National Technical Manager with Base King LLC. On Thursday, February 25, join us for commercial flooring from planning to installation, a comprehensive review, presented by Daniel Ortiz-Bacon, Technical Services Manager, Lidditz Flooring, a Capri Collections company. And on Thursday, March 4, join us for the risk of high moisture in flooring, what you need to know, presented by David Stowell, Technical Services Specialist, and Curtis Colgrove, SIM, Technical Support with GCP Applied Technologies. Visit FCICA.com to view and register for these webinars. FCICA has recently updated the safety book, Start with Safety. It is available electronically, free to members, and printed versions are available for $185. The safety book is an essential item to have in your office and on every job site. Purchase it on FCICA's website today. We are pleased to introduce our presenter, Jason Spangler, Flooring Division Sales Manager with Wagner Meters. Presenter Jason Spangler has an MBA from West Texas A&M University and over 25 years of experience working with products in the construction, roofing, and concrete flooring industries. As an advocate for the precision and effectiveness of RH testing, you can find him in hundreds of Wagner's Rapid RH and Orion product demonstration videos. He enjoys providing hands-on, detailed how-tos for each of the products he personally recommends. It's a way to share his passion for a tested method he has observed to be the best option out there. Jason has successfully launched a variety of products to the market, including the original Rapid RH concrete moisture test. He also serves on FCICA's executive board as a secretary-treasurer. Welcome, Jason. We're excited to have you. So I'm now going to turn the controls over to you.
Thanks, Christine. I appreciate it. I always hate hearing all that, or some of that stuff anyway, when people introduce me. So first of all, thank everybody for being here. I guess for quite a few of us, maybe we are in the afternoon. For me, it's still first thing in the morning pretty much. Thanks for spending your time with us, or spending a little bit of time with us. And one thing I always say, I'll do my very level best to hopefully keep you guys awake for the next 45 minutes or hour or so. And hopefully there's at least a small nugget of information that you can get out of what I present. There's going to be a Q&A session at the end, so please make sure we'll get to as many of the questions as possible. At the end, there will also be a slide with my personal information, so if there are questions that you either don't get answered or that come up after the fact, please feel free to reach out and get a hold of me directly, because that's, at the end of the day, that's what I'm here for. So with that, we'll move forward. So when we look at it, I mean, why are we here? We are here because of the fact that we have an industry problem and we have technical difficulties, like for me, that I forget to unplug my phone. Industry problems, approximately a $19 million per week in flooring failures. And that's either directly or indirectly related to moisture in concrete. Now, with that being said, to put a little bit of a humorous spin on it, that's equal to about one semi-foot, 40-foot semi-trailer full of $10 bills, top to bottom, front to back, side to side, that we're just dumping right square in the middle of the landfill. So when we look at those things, you know, realistically, at the end of the day, for any of us that have some type of P&L responsibilities for our business, it would be beneficial to all of us to be able to recoup some of that money. So we look at some of the issues like this. Obviously, this is a residential setting. I always tell people that, you know, there's certain customers that you really, really hope you'll never have problems with. And this happens to be one of those. This gentleman here is a retired engineer. This happens to be his forever home, as he called it. The general contractor and the flooring contractor at this point have walked away from him, saying that the issues are not their problems. And he's made it his calling in life now in his retirement years to figure out how to prove to them that it is a moisture issue in the concrete. So he's going to great lengths to document that. Again, a little bit of a humorous spin. That's definitely not intended to be some kind of skateboard ramp or speed bump or anything in the middle of his room. That truly is what he's living with. We look at some of the different sheet product sports floors. I'm sure that many of you that have been in the business for a while have seen the mold microbial growth along these lines. Personally, I think that is probably going to be one of the next big things that does start to transpire more and more now, in my opinion. Having some of these floating floors that are out there and some of these things that we have that are, the moisture that can stay latent underneath the concrete, possibly in these vinyl, we might start seeing more and more of these microbial issues. This one's pretty impressive. This is an epoxy terrazzo, and you're looking at some almost 3-inch osmotic blisters that we have there. And then here's a pretty common one. This is one that we see, pretty consistently. Now, the part that I find, I guess I'd say interesting about it is that if you look really closely at these pictures, forget about the VCT tile that's being pulled up right there. If you look at the tiles themselves, you'll notice that you can see a black outline around many of those tiles, or the 2 or 3 of them that are in close proximity here. And it's interesting because as I started learning more and more about these types of issues quite a few years ago, I was surprised when I would walk into some of these larger department stores that utilized VCT, because you could see the outline of those 12 by 12 tiles. And the thing about that is that most of that is not because of, you think about it, VCT originally was intended to be, for all intents and purposes, a poor man's solid sheet vinyl. And maintained correctly, installed correctly, you really can't tell that there are 12 by 12 tiles there. It really does look like a consistent sheet. Well, you look at more and more of these and you'll notice that there's a black outline on those. And a lot of times what that is it may not be a catastrophic failure, but that is some kind of reemulsification of the adhesive that's come up through the cracks of that VCT. And then when they go through and do the typical cleaning with the auto scrubbers and things like that, they're able to get anything as far as dirt off the face of the VCT, but in the cracks, they're not able to get down there. And so it leaves that dirt residue that's with the adhesive in there. So it's interesting because, again, this just kind of lends itself to show people that although there may not be catastrophic failures, there are probably floors out there that are not performing the way we would have intended them to. The one segment of the finishes industry that I would say is probably the furthest behind, but they've come forward quite a bit in the last 5 years, is the coatings industries. A lot of times coatings tended to be a lot more breathable. So it ended up being a situation where the breathability of those products lent it to the installers to not think about doing moisture testing because they didn't have a lot of issues, or at least they didn't have issues that they could relate to moisture. Well, as we've started to get to coatings that are less and less breathable, we're starting to find out that some of these coatings really are having some issues. And so the coatings manufacturers are really starting to jump on board with doing proactive moisture testing. These pictures that I have circled here are from a pharmaceutical facility that was shared with me. And obviously you can tell that something like that is not conducive for any kind of manufacturing environment. So why are we having so many problems? Well, let's look at it. I don't think there's any of the installers in the audience that would say that the construction schedules are such that you can afford to sit around in your office, put your feet up, eat bonbons, and you have all kinds of time. No, they're becoming more and more and more compressed. And so at some point you get to the limitations of what concrete can physically do in a normal construction process as far as drying. And usually we're not giving concrete enough time to dry. Breathability of flooring products. I'm not going to say better or worse. I'm just going to say they're different. And you're starting to see more recycled content. You're starting to see things like that. So it ends up being something where there can be some more issues, especially if we're not keeping up as on the installation side of stuff with the training and with the approach to what it takes to properly install some of these newer types of products. Changes in adhesives. Again, I'm not saying better or worse. It's just technology changes. They're not like they used to be. And so keeping up on those things and understanding those products really is imperative. Big one that I see a lot of is the repurposing of structures. So you have a situation where you have a 10,000 square foot shell. They decide that they're going to do, the business decides they're going to do a 2,500 square foot build out for offices. And they're going to put a vapor retarder underneath that, but they're going to value engineer out the other 7,500 square feet of the warehouse because it's just going to be used as a warehouse. So they install 10 years down the road. Everything is just phenomenal. Business is booming. They want to stay in the location, but they end up with a situation that they need more office space. They don't need quite as much warehouse space. So what do? They build another 2,500 square foot improvement out into the warehouse, put the same floor, same types of products, same installer, everything. And that new improvement fails. And everybody scratches their head and wonders why. And when you look at it, a lot of times it comes back to the fact there wasn't an intact vapor retarder. So if you have a situation like that, it has to be treated differently. And then I still see situations where I'll have specifications and drawings shared with me where they're either not using a effective vapor retarder, or the vapor retarder is being placed in such a spot that it really doesn't follow, and I'll show you in just a few minutes, it doesn't follow the ACI guidelines for vapor retarder placement when you're putting a low permeable or non-permeable finish on top of a slab. So when we look at the general components of concrete, these are the 5 pieces that you're going to see that are going to be the general components of concrete. The one thing I point out there is the third largest by percentage product in there is water. And so when you think about that, it's a big thing when you really do. So to put that into context, we look at it from a standpoint of what water to cement ratio is. So when we look at water to cement ratio, we have the amount of water to the amount of cement, pretty straightforward. As we increase the water to cement ratio, so in essence, we're putting more water into it, you're going to find that you are going to decrease the flexural strength and the compressive strength overall of the concrete. Permeability is going to increase. And the one thing that we're really concerned about from a flooring installation standpoint is you are going to drastically increase your drying times. Again, it ends up being something that having more water in the concrete to place it and to finish it might be easier for certain trades. But at the end of the day, if we're looking for the best finished product and the best longevity of the project, we need to pay attention to those specific ratios. So just to give you a kind of a general idea of what we're talking about. So here you have a very specific water to cement ratio. Obviously the blue is water, the white circles are cement. As they are combined, there's the chemical reaction of hydration that happens. You can see how those little finger-like fibers come out to bind all that cement together, and that's what gives it the strength. Now, if we alter that water to cement ratio, keep the cement amount the same, but we increase the water, you can see based on this graphic here that you're still going to have the process of hydration, but you're going to find that they're going to be more loosely aligned. And so the strength is going to be lost, A, but the other thing is you're going to have much more water in there that needs to be taken care of in the process of evaporation. So to put that in context, as far as numbers go, most people would recommend that we try to keep a water to cement ratio of 0.5 or less. So if you have a 0.5 water to cement ratio, you're looking at about 275 pounds of water per cubic yard. So that means if we put it in context for a full truckload, you have about 2,750 pounds of water in that one truckload of concrete. It takes about 0.27 to 0.29 water to cement ratio to get that full process of hydration and the hardening of the concrete. And so when you compare that to the 0.5, you can see that we are adding about twice as much water, even at the prescribed levels. We're adding about twice as much water as the concrete really needs to get hard. And we're doing that strictly for and again, there's other reasons too, but a lot of it is strictly to make it easier for the placement and finishing of the concrete. Because if we just try to do a 0.27 to 0.29, you would need somebody that looked like Popeye to try to place that stuff, and there wouldn't be very many concrete finishers and placers that would be happy about it. Reason why I bring that up and try to give it more of a visual is because if we're looking at the fact that we have over half of that 2,750 pounds of water that has to, at least a portion of it has to evaporate, that means that we have several pounds of water per square foot that's going to have to at least partially evaporate before we can put some kind of finish on top of it. So when a concrete slab's poured, again, this is new construction, but when a concrete slab's poured, ultimately what it's trying to do is it's trying to reach some kind of equilibrium with the space. So whether that is the indoor space, so the entire cubic volume of the building envelope or the building itself, or as you'll see in just a few more slides, once you restrict it to the bottom of the slab and top of the slab after you put a finish on top of it, it's going to try to equilibrate within that concrete slab because you've restricted its ability to try to equilibrate with the room. So we talked about the vapor retarder placement. So when we look at the concrete drawing, these specifications that we have here is for a 4-inch slab, the water of convenience and how long it takes the water of convenience to evaporate. So water of convenience is going to be the additional water above that 0.27 to 0.29, and it's there for the convenience of placing and finishing. So we're looking at how long it takes, based on the slab construction, how long it takes a slab to dry. So when we look at that, and the one caveat I'll throw out there too is it's how long it takes the slab to dry once the environment is conducive for drying. So we're talking consistent temperatures, and we're talking reasonably low relative humidity levels. So if we look at that and we stick with that and we go down the left-hand row there and we look at the 0.5 water to cement ratio, as we go across, it takes 82 days if you have a slab in that circled one, that you have a slab, that blue line is a vapor retarder directly underneath the slab, and then you have your sub base underneath that. It's going to take 82 days for that slab, for that 4-inch slab, to dry to a reasonable level. Now again, as we go across, you can see that the next slab construction in that middle, that blotter course layer with vapor retarder, what they've done there is they've done a slab, some kind of sand or some kind of blotter layer, and then a vapor retarder below it. It's going to take upwards of 144 days. And then we move forward with no vapor retarder. In essence, though, to be honest, no vapor retarder is never really going to dry because the water of convenience may come out of it, but you still have the potential because you have no barrier between it and the soil. You have no way of knowing if that moisture from the soil is going to make its way up. Point of bringing this up. When you look at the one that I have circled there, that is when you look at the American Concrete Institute ACI 302, that is their specification for how to construct a slab if you are going to put some type of low permeable membrane on top of the floor, and that is either immediately or sometime in the future. So it's just something to keep in mind. That is one of the recommendations. Now, it doesn't mean that's the way it always is, but I'm just saying that's one of, from a very strong association, that's one of their recommendations. One of the arguments about doing it without the vapor retarder underneath from the concrete industry sometimes is the fact that it takes longer for the slab to dry. And the reason to show these numbers here is you can see that that is not true. So a couple terms that you hear used interchangeably, and they really are not interchangeable. Curing versus drying. So if we look at the curing of a slab will happen on a stopwatch. You can take the concrete and dump it in the middle of the ocean. It's going to get hard. Curing is the physical process of it getting hard. It will get hard. And it will get hard on a prescribed time. Usually you're going to find that when they start looking at compressive strengths and how to prove the compressive strengths through the new construction process, you'll usually have some samples that are poured out of various truckloads, and they'll have 7-day break cones that they do and 28-day break cones that they do. And what they'll do is they'll put them 7 days later, they'll take these and put them in a hydraulic press. They'll press them down, and at 7 days, you should be at about 50% of what the prescribed PSI is. So if you have a specification that says 5,000 PSI, you should be at about 2,500 PSI. And then you're usually looking at, not that it's usually higher than this, but you're usually looking at somewhere in the 80 to 90% compressive strength at 28 days. Conversely, when you look at drying of the concrete doesn't physically happen until the environment is conducive for that drying. As I said, you have, the slab trying to reach some kind of equilibrium with the space that it's in. Well, if you have a slab that's 100% relative humidity, that's a new slab, and you have an environment up here that is, staying between 80 and 90% or 80 and 100% relative humidity because it's not enclosed, or the temperatures are fluctuating up and down, things like that, you're going to find that there is no ability or incentive for that moisture to move out of the floor and to escape out of the concrete. Also, you're going to find that if it doesn't stay consistent up in the environment, that you might actually have some of the evaporation happen from the concrete, but as the conditions change in the room, because the slab is like a sponge, it can absorb and expel moisture. So you may evaporate some of it, and then you'll find that it will just go right back into the slab. And that's one of the reasons why it's very critical to make sure that we have a situation where you try to get those environmental conditions as consistent as possible, as quickly as possible. So when you look at that, just to back up for a second, when you look at that, a rule of thumb for concrete drying, once we have a environment that is conducive for drying, so consistent temperatures, low to moderate relative humidity, you're going to find that it's going to take 30 days for every 1 inch of slab thickness for that slab to dry down to about an 85-ish% relative humidity. So it really is it's a time thing, but it's a time thing based on once we have conditions that are in place that make it reasonable to dry. Being on the graphical, I try to be on a little bit more graphical about things, because sometimes hearing somebody just sit there and go like this gets a little bit tiring. So what you're seeing here is you're seeing a slab. It's been poured. The line that is below the light gray is a vapor retarder. So we have this slab constructed the way I had talked about would be proper for putting a finish on top of it. Having a reasonable conditioned space in the air, you'll find that slab will start to profile. And when I say profile, it's going to start getting drier on the top, and it will be wetter on the bottom in comparison. Well, again, that's because it has equalized with the room. There's a pressure associated with the moisture, and it's found its I like to say, its happy place. So it's equalized with the room. Now we're going to come back in and we're going to put a floor on top of that. As I said earlier in the presentation, ultimately the moisture is trying to equalize within whatever the confines of where it's at. So we have a vapor retarder underneath it. We have a low permeable membrane on top of it. And so now, instead of that slab being drier on the top and wetter on the bottom, what's going to happen is it will transition to an equalized state. Now, again, this isn't going to happen on a stopwatch. Not going to say it's going to happen in 2 days or 3 days or however long, but it is going to eventually happen. Between those two layers, it will equalize. The relative humidity from top to bottom will equalize. So as you can see, you end up with a situation that if you were just testing from the surface of the concrete, you would get a lower than what would be expected number than after when you install the floor. So this allows you to be able to see what's going to happen on the surface, prior to it physically happening. Now, if we don't have a vapor retarder, you look at a situation like this. We may have gone through, we may have installed the floor, everything was fine. But now, because we don't have anything that's breaching or that's keeping that moisture at bay from the sub base, you end up with a situation where the moisture keeps coming up and you end up with a failure. So we have a couple of different methodologies of moisture testing, and obviously a few different methods, but you have a qualitative method for testing, which in essence is going to allow us to have an indication that there's moisture present, but not know how much or how that really is going to relate to any kind of flooring performance. So in the qualitative arena, you have the plastic sheet test, and then you have non-destructive electronic meters. On the quantitative side, so something that'll physically give you a number so you can make a yes or no decision based on the concrete and the flooring installation, you have the calcium chloride test and then the in situ relative humidity test. I'm going to tell you, so since 2005, took a small sabbatical, but since 2005, I've been doing this. I'm going to tell you that this right here, and no, this is not a technical issue that we're having. This right here is still one of the most common methods I see out there. People will call me up after a floor's failed and they'll ask me, I have this, and this going on. What do I do about it? You start having a discussion with them and, did you do moisture testing? No. Well, I mean, it's really hard to have or to help somebody after the fact when it would have been so much easier to give some kind of advice or direction beforehand. So moral of the story, do some type of testing. I'm going to show you a few different here, but do some type of testing. So we look at the plastic sheet test. The plastic sheet test does have an ASTM standard. It's very specific about the number of tests. It's very specific about the size of the poly you use, the thickness of the poly, the diameter of the duct tape. And it's going to be good for putting down on there. And what's going to happen is you leave it for a duration of time. And if there is issue, you will start to see some discoloration in the concrete. You might see some formation of condensation on the plastic. Now, it's not to say that that's not showing you something, but it's definitely not telling you for sure, A, how much or where that's really coming from, because there's a lot of people, including myself, that would debate that a lot of what that's showing you has nothing to do with the concrete or the moisture coming out of the concrete, but it has more to do with potentially dew point considerations and the surface temperature of that concrete. And so not to say that that's not an important thing to look at, but that's definitely not something that says yay or nay to, doing the installation exclusively on its own. So we look at the calcium, we look at calcium chloride testing. Calcium chloride testing, when you look at it, it started off as a quantitative test, and then it transitioned back in the 60s to a quantitative test. Really didn't have any of the backing of it, but people were demanding some physical way of being able to say yes or no to something. And you see what I mean when we start looking at these are the designs of the original calcium chloride test. But when I say people were demanding some type of an absolute or a number, this was out of the Rubber Manufacturers Association manual in '63. And if you see that one spot, it says, if there is no sign of moisture, no visible change. Well, your definition of visible change and my definition of visible change can be totally different. So having more of an absolute number obviously makes it better. So real quick, what we've learned since 1997 about calcium chloride is that when we look at calcium chloride, it's drastically biased by ambient relative humidity and temperature, biased by water to cement ratio. The use of lightweight aggregate, it's actually banned if we're using any kind of lightweight concrete or lightweight aggregate concrete. And the fourth one that's there, it could still be an issue, but they have done a better job about specifying the preparation for the site where the test is going to be done. But what I found is not a lot of people have kept up in those changes. So that's why, in just a second, we'll go through that real quick. But when we look at where that moisture vapor emission is coming from, If we look at this, the vertical axis, this vertical axis is the depth from the top of the slab to the bottom of the slab. And if we look at the horizontal axis, we're looking at the percentage of the result that you're getting from a calcium chloride test. We're looking at where that's coming from in relationship to how far into the concrete. And what we found with this is that, you're in essence, you're getting most of your ratings that you're getting from a vapor emission test are coming from that top 10% of the slab. So about the top half inch of the slab. So a calcium chloride really is only showing you what's happening on the top half to 3/4 of an inch of that concrete slab, best case scenario. And obviously with another 3.5 inches below, there's a lot more going on down there than what we have just at the surface. So when we look at this, the steps for conducting a ASTM F21 or an F1869 test or a calcium chloride test, I bring this up and show this just because of the fact that, one, I think it's good for people to understand this process has changed in the last 3 or 4 years. So you have 3 tests for the first 1,000 square feet, one test for every 1,000 square feet after that. When we look at that, there is a rationale for that. It's going to be the same for relative humidity testing. And what it comes down to is the 3 tests for the first 1,000 and one for every 1,000 after that. 1,000 square feet, a 4-inch slab roughly, is going to be about 1 truckload of concrete. So what we're trying to do is we're trying to ensure, what the ASTM standard is trying to do, is ensure that you have a good sampling of as many of the truckloads as possible, because there can be variations. And so capturing those variations prior to installing the floor is obviously much more beneficial than after. So once you've identified where you're going to place them, you're looking at doing a 20 by 20 area for each one of the test spots, and you need to grind it to a CSP1 or CSP2 profile. Interesting thing about that, prior to this revision to the standard, it just said something to the effect of cleaning the spot or making sure it was clean or free of any residue. Well, unfortunately, that's different in everybody's mind. I had some people that would grind it, some people that would sweep it, and that was pretty much it. The other thing that changed, if the concrete's fresh, over 30 days old, never been installed upon, you can grind and set the test right away, and then wait your 60 to 72 hours, get your results. If the concrete has been installed upon, the test site needs to be ground. You need to walk away for 24 hours, and then you can come back and set your test and wait 60 to 72 hours. So in essence, you have an extra day that's been thrown in there that you have to wait. So we move on to in situ relative humidity testing, and we look at ASTM F2170. One of the things that was interesting to me was back in 2005, when I was going around talking to large commercial contractors about this methodology, they thought it was great. They got to a point where they thought it was perfect. It was something that really would work well for them. But unfortunately, when they started looking at the cost and the idea of not being a proven method, definitely was an obstacle to overcome. But when we think about RH testing, has been around since the 50s. Several countries have flooring standards that have been around since the 80s. And the bottom one here is that this standard or this testing methodology is really based off scientific research or a premise of scientific research that was done in 1997 over in Sweden. So we really do have a scientific pedigree to back up this type of testing. So this one's a lot to take in, but I'll see if we can get it. It's usually a lot easier to do when I have pointers and stuff like that. But if you look at the horizontal axis, that's again from the top of the slab to the bottom of the slab. The vertical axis. If you look at the horizontal axis, you're going to see that's the percentage of relative humidity when you're testing it at those specific depths. So when the concrete's poured, you look at this red line. The red line from top to bottom, you're a consistent 100% relative humidity throughout. As I've said more than once during this presentation, you're going to have a situation where you have a moisture gradient that develops in that slab, which is what the yellow line is. So you're going to have less moisture on the top, more moisture on the bottom. And what this scientific research wanted to prove was at what depth within that concrete could you find that number that you would achieve prior to installation, but once the moisture re-equilibrated and raised to the surface, would also indicate that number. So you're able to see what's going to happen on the surface prior to the installation. And what this scientist found out was that at that 40%, when the slab was drying from one side, was that intersection point of where a slab had dried down naturally, had been encapsulated with a low permeable membrane, and then the moisture had equilibrated. It allowed you to see and predict what was going to happen. More on the visual side, if you look at this, the top is 74%, you have 85% and 99% at the bottom. You take a reading at 40%, you end up with a situation where, as you can see, once you put the floor on top of it, you have 84, 85, 86, but you notice that the one number that didn't change was that 40% number, and everything else re-equilibrated. And as I said earlier, the surface relative humidity increased. So as with the calcium chloride test, you have 3 tests for the first 1,000 square feet, 1 test for each 1,000 square feet after that. I will say, to get the best results with any of these tests, you really do need to have the conditions in that building at service conditions. So whatever conditions they are going to be when people are in it, that's what you should be testing at. Same number of tests based on the same functionality of a truckload of concrete. The depth of the hole, it can vary if you have a slab that's drying from 2 sides. So a elevated slab that's structural in nature, you have concrete on the top, you have concrete on the bottom, then you would only drill into it 20%. As opposed to a slab that's drying from 2 sides, you would drill into it 40%. You put your sleeve and sensor combos in, you wait 24 hours, get your readings. So the great thing is, obviously, is we've taken this test methodology and decreased it down to 24 hours, so it makes it a lot more conducive for getting tests quicker. So what this is quite a few years ago, we asked different independent people that were out there doing a lot of moisture testing. We asked them to provide information where they had tested relative humidity and calcium chloride in the same spot, because we always had these people asking what are the comparisons. And so each one of these triangles that's here is a spot where they did relative humidity and calcium chloride in the same spot in the concrete. Results on the vertical axis are the pounds of vapor emission for 24 hours per 1,000 square feet, and your relative humidity reading on the horizontal axis. Now, this area that I have lined out in the red, those are the spots, or those 2 test spots, are where relative humidity and calcium chloride testing, they agree with each other from an installation standpoint. Products that are out on the market right now, I haven't seen one that if you didn't hit at least 75% relative humidity or below that you could install. And most of the time, 5 pounds or less, you're going to be okay to install products. So these 2 areas, these 2 triangles that are below that red line are areas where, in general, installation is okay. Well, that's fine until you start looking at the comparison up here. When you look at the comparison up here is where the calcium chloride test is telling you, yes, you're good to go, but relative humidity is telling you that you need to pump the brakes and pay attention to, some of the situations that are out there. It doesn't mean that they all are going to be relative to each other from a standpoint of, down here where you can make installation decisions. It doesn't mean that 3 pounds is 85% or 3 pounds is 60%. It just means in general that you have certain areas, and one of the areas where you're going to find that they do in general mesh is usually going to be up in the very high areas. If you have a very high vapor emission, very high relative humidity, a lot of times you're going to see where they're going to match. Where you see these situations where they might be lower on the surface and not relative humidity wise is depending on what the conditions are in the concrete or what the testing process was for the calcium chloride test. So now we're going to get into specific product stuff. For Wagner meters, we have 2 different systems that are out there. We have a Rapid RH L6 system that's out there that just came out a couple years ago, or it was the latest version of the Rapid RH family. And then we have a Rapid RH 5.0. With the Rapid RH L6. The L6 is a single usage sensor. So meaning that the sensor goes into the hole, it stays there, it gets left there. And the reason for that really is because that makes it the easiest product to comply to the ASTM protocol from the standpoint of a NIST traceable certificate of calibration that's given with every single packet of sensors that you get. So you don't have to worry whether or not the product you're using in that hole is accurate or not, or being able to prove it yourself, because we are proving it for you. You can put it into one hole, but you can use it multiple times in that same hole. You can take different readings. There's no waiting for test results after you've left it in for that initial 24-hour equilibration rate, because inside that sleeve is a sensor, and if you have a cap on top of it, it is sitting there in that same environment the whole time, so you can just come back, take the cap off, and take a reading from it. For those of you that are familiar with the earlier versions of the Rapid RH, this new L6, the raw sensor inside of it is definitely a lot more responsive in those higher relative humidity, 90 to 100% ranges, which has become more and more critical to a lot of contractors out there. The other thing is that there's memory inside the sensor. So every time you take a reading, it stores it in that sensor. So in essence, you could find, as I'm going to show you a video in just a second, you'll find that we really have looked at this thing from an entire system standpoint to try to help you guys document and keep the best information possible to make installation decisions, and then after the fact in case there is an issue. So now I'm going to play an installation video real quick, and we'll be back to you in just a second. Okay, So it gives you kind of an idea of the installation process for the L6. Installation process for the 5.0 is, fairly close. There are some nuances because, it is a different type of system, but you kind of get the idea, and I'll show you even more in just a second, but you get the idea that, this is an all-encompassing system. I tell people it's a great product, but it's something where we really tried to come up with an entire system for the installers and for people to be able to utilize this product. So when I say that, you have the situation where you can take the reading and it stores it in the sensor. So at the end of the day, if there's ever a question, if the numbers that you're providing to somebody actually came from that job site, you could take the reader, because the reader is Bluetooth capable, and you can extract all of that data out of the memory. So it allows you to be able to have another level of data integrity specific to that job site. The metal discs. The metal discs are really there for people to be able to, at the end of the day, once prior to installation, just before they get doing their final floor prep, to skim those into the floor, because push comes to shove, you could go back and find those. If you document correctly, you could go back and find those sensors and be able to physically prove that what documentation you have does relate to that specific floor if there is an issue. We're just trying to figure out every single way to make it an entire system to help everybody have the best documentation process possible. So when we look at some of the differences that we've made between, or improvements that we've made, because one of the things that I will say that I pride myself on for our company is we try to really listen to what people are saying. And as you go through different iterations of a product, you try to improve upon it, obviously. But one of the things we had, the caps, people said the caps came off a little bit too easy. So what we've done, there's now a butyl rubber ring around the bottom of them so you can put them down on the concrete, and they have a lot more difficult time coming off. Another thing that we did, the total reader, or the reader that we use for getting the readings or extracting the information from the sensor. The previous version we had, they were sometimes a little bit too delicate for, we'll just say, robust users. And so we improved the durability of the pins on the bottom of the reader to make them a lot more robust so they won't break so much. There's an onboard ambient relative humidity and temperature sensor on the reader. So if you're using the app, which I'll show you in just a second, it will actually take the relative humidity and temperature readings in the concrete, but it will also take it above the hole wherever that sensor is on the reader, and it will report both of them, which are two pieces of data or data points that you need to have. Obviously, we have the ability, because it is Bluetooth integrated, we do have the ability to transmit the information to an app that I'll show you. And it allows for temperature and relative humidity readings. If you're using the app, it allows for them to be read to the 10th, which is critical for some of these products that are out there. There's products that'll warrant up to 99, but maybe they won't do 100. With a 2-digit LCD screen, it shows 99, but that could be higher than 99, but it just maxes out at that 99 point. With the app, it will show you it's 99.1 or it's 98.6. It'll tell you exactly what it is. So with the app, we have not only the app on the smart device, but we also have a cloud storage that allows for you to upload that information. So not only can you have the information locally on the phone, on your desktop, but you can also have a cloud version of it. So what does it do? So it just allows for better job site specific data information. You can take, I have guys and gals that are taking blueprints, they're taking pictures of them, or they're integrating a PDF into it to allow them to put it on the phone so that you can go through and you can put in the specific areas where those tests are located that you're placing. So you're able to have a graphical representation of where all these moisture tests are being performed. You notice the green dots that are on this picture. Those are places where you can just push them around. They're push pins that you can put them wherever they're at. As you take the readings, you're able to save them to this, but you can have the job name, you can have the address, you can have all the information you want on here, and you're able to get from point A to point B very quickly with a couple of swipes. You can generate a report and send it off via email directly from the job site. So when we look at, so now we move forward to the Rapid RH 5.0, which is a reusable sensor. So this sensor, a lot of it looks exactly the same, but with any type of reusable sensor, there's some different nuances to it. So theoretically, with the 5.0 sensor, you can use, or any reusable sensor, you can reuse them for up to 12 months. They will require you as the user to verify calibration of the sensor every 30 days. And the sensors will be required to acclimate if you don't leave them in the hole. You either need to leave the sleeve by itself in the hole without the sensor for 24 hours and then come back and put the sensor in, or you have to leave them in and then leapfrog those sensors if you don't have enough sensors to physically populate all the holes. Price on the reusables is more expensive, but theoretically, if you use them and you're used to doing the maintenance and you're okay with doing that calibration verification every 30 days, they can be a good option. Procedurally, the same thing. It just depends on how you're going to use them or how many of those reusables. What I like to tell people about the 5.0 or any type of reusable product that's out there, though, is that it's going to be a time or money proposition. You're going to find that it's going to take longer and you're going to be responsible for more when you look at using a reusable product versus using something like the L6. So we move forward to the Wagner Smart Logger. So trying to kind of tie all this stuff together. When you look at it, the Smart Logger is a ambient data logger, can be used, put on a job site. A lot of times I'll see people will put it on during the time of doing the concrete moisture testing, but they'll also leave it during the acclimation of product time, and they will also do it at the installation duration so that they can have all of this information about the relative humidity and temperature in that environment during that process so that they can have better documentation if there ever is an issue. Again, all of the information extracted via Bluetooth, and you end up with a situation where the better documentation you have, the better decisions you can make. So tying up the Rapid RH L6 part, I talked about the whole system, and I always push it to the nth degree, something kind of going back a little bit. But when you look at the fact that you're going to drill a hole, you're going to put a sensor in there, you're going to take a reading from that, and every time you take a reading, it's going to store. If you use the app, you're able to tie and have all of that information on the app. You can generate a very professional report. The data that's in there is in a secured PDF, so there's no question as to whether or not there's any funny business going on with trying to elevate the numbers to, get mitigation out of or anything like that. It is what it is. It's transmitting the information, you're capturing the information. If after all that's said and done, so the documentation process is better. On the other side of it, if you skim that metal disc in, you have all those pieces to tie together. So let's say that there is a flooring failure and somebody wants to question whether you did moisture testing. You provide the information that I just said. And they said, that's great. How do I know it's actually from that job? Well, I'm glad you asked, because very inexpensive metal detector, you could actually take the information you have, go out to that job site. Because you have the location of the test, you could find those general areas with that metal disc in there. You could find those areas, and you could prove that the test that you have tie to the results that you gave to somebody. One step further, if there hasn't been something catastrophic, you could take that reader and put it down in there, and you could upload all the information out of that memory that's in that sensor and be able to prove those two things tie together. Again, all about data integrity. So a couple of different things for us, Wagner specifically. I would challenge any of you to go out, look at any of the stuff that we have out there as far as additional resources, articles on topics. Not everything is about just Rapid RH and moisture testing and things along those lines. You're going to find that we really do try to embrace any of the issues that you guys are having out there and try to have discussions or facilitate discussions to help you have information to be able to make those better decisions. We also have microsites like the RH Spec app. You're going to find there's a 3-part formatted CSI specification in there for moisture testing. You're going to find that there's some other very specific information in there for the specification side of things. And then we have another one that's called AIA spec. The AIA spec has an on-demand moisture testing webinar that you can go on and take. Definitely something that if you have customers that you want to try to educate or try to get them to see stuff, definitely a good resource. And with that, that's the end of my presentation. Here is my information. Please take it down if you don't have it. If you have any questions after the fact, let me know. Christine?
Oops. Here I am. Thank you so much, Jason. Now we have an opportunity for the audience to submit questions. We've gotten a number of them already, so I'm going to facilitate those. Jason, the first question is, can moisture in a slab move sideways or only up or down?
That is a great topic of discussion. So most people that are a lot smarter than I am will tell you that you're going to find that the way the consistent capillary structure on the concrete forms, that you're going to have only movement north to south. At best, it may move laterally. The thickness, a lot of what I've heard is the thickness of the concrete. So if you have a 6-inch slab, it's usually just going to go up and down, but side to side, it may move, 6 inches either way if you have a 6-inch slab. Now, where it could move laterally is if you don't have an intact vapor retarder. If you don't have an intact vapor retarder, then the ability for that moisture to, and when I say move laterally, it's not move laterally as much as the fact that it can actually get from point A to point B and move up in the soil. So, that's where that intact vapor retarder is definitely a very big thing.
Okay, thank you. Yeah, I'd forgotten to announce that if you have questions, you can enter them in the Q&A on the left side of your screen. So the next question, Jason, is that there was a comment saying that the qualitative measurements for moisture meters, they didn't notice that on one of the slides. So do you have anything to say about that, the qualitative measurements for moisture meters?
Yeah, and that's a great concept. I will tell you, I was actually surprised when I was going through this because, not that it's an excuse, but a lot of my slides are animated, and unfortunately, I had to pull some of the animations out, and it looked like that I pulled that one out on accident, and I actually didn't mean to. So the qualitative measurement for electronic moisture meters on the surface, which is ASTM F2659, it definitely is a great tool to use for initial investigation or placement. What it's intended for, if you read the ASTM standard, is 2659 is meant to use an electronic surface meter to be able to identify what I would call hotspots. And in those, you can move around very quickly and scan and find where the numbers hit the highest. In those areas is where you can sit there and say, okay, I need to do further investigation with a quantitative method. So it's great for identifying where to place your calcium chloride test or where to place your relative humidity test for further diagnostics on the concrete.
Okay, next question. Getting slabs to 75% RH is not really practical. 85% seems more realistic. This gentleman would like your opinion on this.
Yeah, I saw who sent that in, and I appreciate where he's coming from. Yeah. So first thing is, real quick, where did 75 come from? 75 came from a general number that was when the ASTM standard, when F2170 was originally published in 2002, having something out there, it became very difficult to have a standard out there that there was no relationship or information from the manufacturer side. And so 75% came from some different European stuff that had been done over there. And when I say 75%, it was put in there And yes, it is very difficult. Have I seen them? Yes. Few and far between, but yes. So that's where it all started off at. They had to have something to work with. Now, what you'll find that as time has gone on, that the different manufacturers have started to do testing and started to establish different thresholds because of what they now know. What they now know as being something that will help with the overall process that they're dealing with. So products will withstand more moisture, and they've started to test them. So my thoughts, yes, I think that having anything in there that says 75 is probably going to be something where at the end of the day, what that's saying that you have a need for some other additional adhesive or some other additional mitigation product or something else, because you getting there is going to be very, very difficult, if not impossible.
All right. Next question. Can you explain if and or how silica gel admixtures may or could affect our in situ readings? We are seeing silica gel a lot more, and it is a hard topic to research. Any knowledge on silica gel admixtures would help. We are told it makes the concrete dry faster and harder by others, and that is all they offer up. Where does that water go?
Well, and there's probably somebody on this call that's probably even better at that as far as discussions than I am. But what I will tell you is, at least what I've seen and what I have found, heard, is that most of the time you're going to find that the relative humidity probes in the concrete with some kind of silicate admixture to it, the numbers are still going to read high. What it comes down to is the debate of, what's really happening with that and proving what's happening with that moisture. Is it free moisture? Is it bound moisture? And, I mean, at the end of the day, it really is one of those topics in the industry that still is difficult. I think that probably having a full-blown discussion on that in and of itself, without trying to be too over scientific about the presentation, I think is probably something that would be a good benefit for the entire industry. The question is going to be, and you're going to get different opinions from different people, is, are the silicates really working? And silicates in and of themselves were intended to be densifiers for the surface of the concrete. And the debate that's out there as to whether or not they actually work for diminishing moisture when we're looking at the longevity of flooring finishes. That's the biggest debate.
Next question. What moisture content percentage is ideal for polished concrete?
Moisture content percentage. So just so I make sure that and I'm sure the person is not meaning this specifically, but we're not talking about, in this specific application, what we're saying, we're not talking about moisture content percentage. We're talking about relative humidity. So two totally different things. But from a polished concrete standpoint, a lot of times it's not the polished concrete in and of itself. It just depends on what you're going to put on top of it. Most of the time with polished concrete, you're not going to have any kind of, usually from what I've seen, you're not going to see any kind of, this is what the moisture levels need to be. It's where you're starting to put colorants into the either topically or integrally applied, where you're starting to see that there can become some issues with that. Most of those finishes like that, you're going to find that they're going to have, as the person earlier alluded to, they're going to have 75% relative humidity in there, because they really haven't done a lot of research into what's going to cause a finish or a color to blush. So that's where you end up with a question about it. But if you don't find documentation for something that you're trying to apply to the concrete, then your safest bet usually is going to be to go, if you're using relative humidity testing, use 75%. But I would always recommend going back to the manufacturer of whatever products you're using and getting them to give you something specifically.
Okay, we have time for one more question. And that question is, you mentioned ACI 302.2R06 for water to cementitious material ratios. That document also states there is no relationship between the relative humidity of a concrete base or screed and adhesion of resilient floor coverings. If that is the case, what direct value to an OR does RH testing provide?
Well, I guess I guess there's a million opinions to everything. ACI 302 has some very specific documentation on what we're looking at from a slab construction standpoint. We have scientific research that says just the opposite. So, what it really comes down to is trying to push the information that's out there from a scientific standpoint. When I say the stuff about ACI 302, my biggest thing about that is looking at the overall construction of the slab itself. When I look at the relative humidity direct value to the floor coverings, I have to go back to Hedenblad's information that he did over in Sweden in 1997. So I guess that's about all I can say about that.
All right. Thank you so much, Jason. Unfortunately, we're running out of time. So if you have any additional questions, please feel free to email them to me and I will forward them to Jason. So if there's no more questions, then on behalf of FCICA, thank you, Jason, for presenting today's webinar. SIMs may now navigate to the Submit Credit tab to receive credit. Please note that you must be signed into the educational platform for this feature to work. If you have any issues, please let us know. This is the conclusion of the webinar. Thank you so much for joining us. Have a great rest of your day. Thank you so much, Jason.